we looked in the previous class was types of mechanisms, secure and precise. And then we went ahead to we said that
what diagrams are those?
It was like an illustration to like make us understand those two formulas or equations that you gave.
Okay.
Yes.
Okay.
We looked at trust and trust, all aspects of security.
Okay.
And therefore, trust cannot be quantified precisely in design and implementation.
Okay.
Then you left us a question to research that the implementation of security mechanism.
Okay. Okay, fair enough. Stephen Wanye. He's left out.
Maybe I can see the different and the types of mechanisms where there's some definitions on the reachable and some like terms when used to cover
Okay.
the mechanism where there are secure mechanisms where the mechanisms states covered in the set by the policy.
Okay.
Then precise. The secure ones is if that of its policy in the policy in the mechanisms are some states in the but
okay. Anything else? Yes. Okay, so we looked at types of threats that we could have. So we have those that focus on disclosure, deception, disruption, and usurpation. What else? Anything else we've left out? Just a quick clarification on the types of mechanisms. So we will have secure, precise, and broad. And when we look at these types of mechanisms, we have to understand the different states that a system can get into. Yeah. So if you look at the different states that a system can get into, regardless of whether the states are secure or not, that list of possible states is the biggest subset. Yeah. Then, other than this list of possible states, we also have another smaller list, which is a subset of this bigger list, which is a set of all secure states. Yeah. So the set of all secure states will definitely be slightly less than the total number of states that can be reached. Yeah. Then there are the number of states that we can reach if a mechanism is in place. Yeah. So we again have another subset, either of the secure states or the entire category of states, which is represented by the states that are reachable when we have a particular mechanism in place. Yeah? So we have three sort of sets. Yeah? Total number of states, total number of secure states, and total number of reachable states, assuming a mechanism is in place. Yeah? So if the total number of reachable states, assuming a mechanism is in place, is a subset of the total number of secure states, then we have a secure system, or we have a mechanism that ensures we more or less have security. We can have a scenario where the total number of reachable states when that mechanism is in place is equivalent to the number of secure states. Then in that case, we have a precise mechanism. Yeah? But if we have a scenario where the number of reachable states, assuming that mechanism is in place, is outside the secure states, meaning part of it is in the secure states and part of it is in that general states that can be achieved, assuming nothing is in place, then in that case, we have a broad set of mechanisms. So ideally speaking, we would want to achieve secure or precise sort of mechanisms. Practically speaking, it wouldn't be possible, yeah? Because it is not possible to cover all possible facets of security. Yeah? That is why we normally have what we call zero-day attacks, yeah? Because organizations will come up with mechanisms, with applications, and they will test them for different security vulnerabilities. And probably based on those particular test cases, the application is more or less considered secure. But after a number of years or weeks or months of usage, then we come across some vulnerability that was not anticipated. Yeah? So we realized that it was possible for that application or system to move to an insecure state without the developers or the owners of the application actually knowing it. So practically speaking, we will always have a broad sort of mechanisms, yeah? Unless our system or application is very small in scope, or the system is completely air-gapped and we do not have any sort of vulnerabilities from external access. Even in those cases, we will still have possibilities of having internal threats and attacks. Okay, so what exactly do we mean by states? So states, if you have a system and you have activities or events that are carried out by users, so what happens is a particular process moves your system from one state to the other. Yeah. So if it's about access to files, then you probably have a system that is idle, and then you access a file and you have some resources that are currently being used. So you've basically moved your system or your application or whatever it is you're working on from one state to the other. Yeah? So it's that change in parameters, change in global and local variables of that system, because a particular process is modifying part of the application or the system. That's what we mean by state. So a reachable state is basically all possible states that can be achieved in a system, from when it's launched to when it's completed, when someone is no longer using it. So all these are reachable states. Some of these states might not be desirable. Yeah. For example, if you're working on a web-based system, when you launch the system and when you initiate the connection to the DB, then you have a different state. Yeah? If you're done with the system and maybe the connection to the DB is not closed, then we wouldn't want to leave the system at that point. We have an open connection that no one is using. Yeah? So these are some of the states that a system can get to. Some of the states are undesirable, are more or less we leave the system vulnerable, and others are secure. Yeah? So a set of all reachable states, and we can also have a set of all secure states as a subset of all reachable states. So I hope that answers the two questions that I just saw. Now, the next bit, which was more or less what you were meant to look at as a reading assignment, is this fundamental design principles, which is the basis of this class. Yeah. So we have a couple of principles that have been defined by different frameworks, by different bodies that define best practices or guidelines in security. Yeah? So eventually, there is a list of principles that can be agreed upon across the discipline. Yeah? Now, the principles inform how we come up with applications, how we logically and physically secure applications or systems, how users are trained. So these principles define all the facets of information security and consequently the security of these facets. Yeah. So this will revolve around the applications, the hardware, the network, the users, the storage of the data in transit, many other aspects of it. Yeah. So the first principle that we are going to look at is a principle of economy of mechanism. Yeah. So based on your reading, what do you think this principle means? Principle of economy of mechanism. You could use an analogy or an example to explain if you so wish. Alan Vikiro, what does this principle mean? Economy of mechanism.
Okay, from what I understood from the economy of mechanism is that the mechanisms and the policies that you make should not be as complex as, should not have a complex design, because it would be hard to kind of trace your way through the policies. And in case anything happens, you'd want something that's simple to work with. So yeah, that's what I understood by it.
Okay. So yes, any security measures that you want to implement should be as simple and small as possible, small in terms of scope. Now, the idea is to try and reduce ambiguities. Yeah. So we want to have the simplest possible mechanism that we can have in place to probably protect access to files. Now, if a particular mechanism, maybe a simple password to a file, is enough to provide security for that access scenario, then that should be the mechanism that is used. Yeah? The idea is to not use, say, multiple security mechanisms to do the same thing. Yeah? To have redundant mechanisms. Yeah? Redundant in the sense doing the same thing and not probably hardening other layers around, say, the access system. Yeah? So the idea is this makes it easier to not just maintain the mechanisms, but troubleshoot in case you have problems, to change in case it's not sufficient. Yeah? And eventually easier for users to understand and to work with compared to more complex or more set of complex mechanisms or combinations of mechanisms. Yeah. So simplicity is always important. Yeah. So the idea is to avoid ambiguity, to have easier tracking, tracing of the mechanism, easier maintenance, easier replacement. Yeah. Then we have a second principle, which is the principle of fail-safe defaults. Yeah? principle of fail-safe defaults. So what do you think this principle refers to? Bansi, karaoke.
I honestly don't know.
Sorry?
To be honest, I'm actually searching. I don't have it.
Okay. Tyrone, Reina,
I think what
principle of
yeah
fail-safe default.
what it says is that unless an interaction of the system is explicitly given access to, let's say, a service, then by default it should be denied to any other.
So why is that the case? Why is it important to have an implicit denial and explicit permissions?
I think if you have that, you prevent global users from accessing services or doing anything that they're not allowed to do.
Okay.
Yeah.
Okay. Any other take on fail-safe defaults? Cosmos, Nairo.
Can you hear me? Hello.
Yes, I can hear you.
Hello.
Yes, Cosmos. Okay, Rebecca, Bula.
I think it's pertains to access of certain functionalities in a system, such that unless a functionality is essential to a user, they don't have access to it, so that it prevents users from making changes that otherwise are not necessary or might pose a breach to security, in my opinion.
Okay. So in fail-safe defaults, the primary idea is to always protect data, the confidentiality or integrity of data. So by default, we always have restrictions. We do not have permissions. So we have denial of access unless permission is explicitly granted. Yeah? Now, in case the mechanism fails, then we assure that the access to the data will not be allowed. So these fail-safe defaults always ensure, one, the data is secure, and two, in case of failure, we can actually detect a failure slightly faster than if it was based on permissions than explicit restrictions. In this sense, if I have 3 users who I give access to this file that I am using to present, so I am using the first 3 users that I have. I have Vivian, Marvin, and Magak. If that was the case, everyone else does not have access. So what happens when my mechanism fails? So I am using some sort of access control, and I have given read-write privileges to the 3 of them. If the mechanism fails, then the 3 of them cannot access the data. It also means the rest of you can still not access the data. Okay? Because the default is an implicit denial of everyone, denial of access for everyone. So in this case, we will still have security of data, in that unauthorized users will not be able to access the data. The authorized users will also not be able to access the data. So what happens? if we were in a production environment, then I will have mails flying all over saying that you need Vivian, Marvin, and Magak need to do their jobs, but they cannot access the data that they need to do the job. Yeah? And I can therefore correct the mechanism. Now, if the inverse was true, if the mechanism was based on giving permissions, defining restrictions, but everyone has access. If the mechanism fails, then what that means is users who do not have access will have access to the data. So again, if I have the three individuals and everyone has access, but I have limited access to Vivian, Marvin, and Magak, then in this case, if the mechanism fails, then Vivian, Marvin, and Magak will have access to the data, which is what we will call an undesirable state. So everyone will have access to the data. Now, how many individuals will actually mention that they normally aren't supposed to edit marks in the AMS, but at the moment, they have the permissions to edit marks in the AMS. So you realize it's also a bit more difficult to track the failures of mechanisms. Yeah? And for that reason, it is a bit more desirable to have mechanisms that are based on granting permissions, where everyone doesn't have access unless the permission is granted exclusively or explicitly, as opposed to a scenario where it's based on permissions, then we do restrictions. Yeah. Quick question to this case, I will choose someone I have probably taught before with regard to this. Let's see. Eric Burugu, are you here?
Yes, I'm here.
Okay. We might have covered this in a different class. So how do firewalls operate? Are they based on restrictions, then explicit permission granting, or the other way around? Are they based on having access? Then you define restrictions.
They're based on having access, based on access control mechanism, like the access control list.
Okay. So what happens? You have access, then we do restrictions, or you are by default restricted, then we give you permissions.
You're by default restricted, then you're given permissions.
Okay. So a good example is when you have access control list in firewalls, or basically the rules you have in firewalls, there is always an implicit deny all, yeah, where no one has access to resources, which means all connections coming in through the firewall will be dropped unless we give you explicit permits. Yeah. So we can only permit you to have access to particular resources or particular nodes in the network. And there is always an implicit deny all at the end of the access control list. Yeah? So in that particular scenario, you will still have fail-safe defaults. Then we move to the next principle, which is complete mediation, which happens in almost every mechanism that we have in place. Yeah? And this principle focuses on checking every request to access a resource against a particular rule base, a particular database of rules that determine who has access and who doesn't have access. Yeah? Now, based on what you've been going through, what are the obvious downsides of having this complete mediation or having an implementation of a mechanism that follows complete mediation as a principle? Additionally, now that I might have examples that tend towards telecoms and networks, from say an ICS point of view, from a programming point of view, what are some of the measures you will have in place to try and reduce the effects of these downsides that you will have in complete mediation? Derek Musuya.
Hello.
Yes, Derek.
Yeah, I think one of the downside for complete mediation is the amount of resources that will be required.
Okay.
Because you will need a database that will be checked for the access controls that have been stored for every particular user.
Okay.
Yeah.
So an obvious downside will be resources. Complete mediation will be a very resource-intensive process, which implies for every request we have to do a check. If you're doing the check across a network, then that means in terms of bandwidth, you have lots of bandwidth, lots of latencies and delays in terms of getting feedback. Yeah, because part of the time in terms of performance, or the turnaround time, the total time, will be the latency that the network has, the amount of time it takes for the nodes to communicate across the network. Yeah? So what are some of the things you do when you develop applications, mobile-based or web-based applications, to try and reduce the effect of this resource usage, resource utilization? Esther Njoroge. Yes, Tyrone.
I'm not really sure, but I think one way you can do it is if you, like in websites, you can cache user credentials so that you don't always have to log in. You don't have to do a login check all the time. Yeah.
Okay. So you can do caching. Caching is one of the mechanisms that you have in place to try and avoid complete mediation. Yeah. But also improve the turnaround time eventually. Yes, Vanessa.
I have a question. When
Yes.
we do caching and we're trying to do complete mediation, so for example, if the operating system, let's say I access a certain object right now, and then the operating system, it adds this to its cache, yeah, and then maybe my access is revoked after maybe the next few minutes. So the next time I can still access it because the operating system will be checking, it will still be checking its cache. So isn't this like a downside of complete mediation?
Yes, that's very true. Not a downside of complete mediation, but what I will say will be the price we have to pay for trying to reduce how resource intensive our process is. Yeah? Which means we always need to do frequent updates of the cache, and not just based on time, the frequency, but every time the permissions change, then the cache has to be updated. Yeah? But the idea behind having or implementing caching is to try and reduce the amount of time and resources we use every time we have to check against the rule base. So it's it's sort of a bypass. Yeah? And the idea is we are trying to make the data slightly more available, but at the end of the day, we might be compromising our confidentiality or integrity based on having this caching in place. Yeah. Yes, Isaac, your hand was up.
I wanted to ask the point where Vanessa has put across, but it's okay.
Okay.
Yeah, but alternatively, also when building web applications, we can use JSON web tokens.
Okay.
Yeah.
So again, we could have use of local memories. So we could store data in our JSON files and probably query them slightly easier, slightly more faster, because we have the storage locally. Yeah. Again, the problem comes in, and this comes in from a distribution point of view. Problem comes in from having updates. Yeah. How often do we update our local memories, our caches? Yeah. So unless the caches are updated or the local memories are updated every time the permissions change or the privileges are either added or revoked, then we will still have compromises in security. Yeah. So these are sort of measures that try to improve the speed of access and the ease of access. Yeah. Then we have the next principle. I hope that addresses the concern. Then we have open design. So what do you think we mean when we say open design? Open design? Yes, Rebecca.
I think it's like sort of like Linux, the way it's open source, everyone has, like, you can easily get access to the source code. So a lot of different like experts get access to the code, and then they can make it better and improve it, make it more secure. So you have like input from multiple people on the like basically the security design.
The algorithm, yeah. Okay. Yes. So the idea behind open design is the algorithm that you're using should not be secret. Yeah. The algorithm behind the security mechanisms in place should not be secret. Yeah. This is simply summarized by a phrase that normally says, normally we do not have security by obscurity. Yeah. We cannot have security by hiding the algorithm that we use. Yeah. Because there are different ways that we can always get to the workings of the algorithm. Yeah? People can do reverse engineering. People can break down hardware and analyze how it works. People can do dumpster diving and get information from an enterprise. Yeah? And the only thing that should be secret should be the keys, should be the passwords, should be the keys that are used to either encrypt data, especially in cryptographic algorithms. Yeah? The mechanism itself, the algorithm behind the mechanism, should be out there, should be open to criticism, should be open to evaluation, so that the strength of the algorithm itself can be tested from an open point of view. Yeah? So the only thing that should remain secret is the key. Yeah? Everything else can be open. There are multiple examples that follow this principle of open design. Yeah? For example, when you look at wireless security, now wireless security is defined by IEEE. So IEEE 802.11i should be the standard for wireless security. and normally focuses on extensible and authentication protocol, I think. So the protocol itself is known. Yeah. When we look at the different implementations in WEP, WPA2, 3, then the algorithm is known. Yeah. If we're using a block cipher and we have a seed that originates everything that comes out of it, then all these are known. Yeah? But the key, the password to the network is what changes. Yeah? But the algorithms or how these cryptographic security algorithms work are still known. Yeah? So it's the same idea. In terms of open design, the algorithm should be known. The only thing that remains secret should be the key. Yeah? Then we have separation of privileges. So what do we mean when we say or when we have separation of privileges? Separation of privileges. James Kabecha. Victor Kimotho.
Okay. So
Separation of privileges.
So I think it's where. Can you give me just a minute?
Yeah, sure. In the meantime, Regan Ogonda, you can help us in the meantime. Yes, Esther. Esther Njoroge. Hello.
Yes. For example, the bank, like a teller, bank teller will have more privileges compared to the manager because if a teller is able to access critical information, that means it's easy for an attacker to access the information, and also the information is vulnerable to human errors. So for the bank teller, he or she is able to access what's meant for his domain, and for the manager, able to access more things because he's able to manipulate information better. Yeah, sorry.
Did you say the teller would have more privileges than the manager?
No, less privileges than the manager. Yeah.
Okay. Isaac?
Okay. For me, I think what it simply means is that access to a particular resource should not be based on only one single condition. Let's say the Linux operating system. For you to actually change like the root user password, you have to know first of all the root password. And then the second condition is that you must be in the group ID 0. So you see, when you know the root password and you're not in group ID 0, you can't change the password. And when you're in group ID 0 and you don't know the root password, you can't change the password. So what I feel like about this principle is that it limits access to system entities, basically.
Okay. Kesley, your hand was up.
I actually wanted to give almost a similar illustration to Isaac's, but I guess he said it better, so it's okay.
Okay. So you need a password and you need to be in the administrators group. Normally comes up as the sudo as file. Yes. So in separation of privileges, you need multiple attributes for you to execute something, for you to carry out a task. So you have multiple users authorizing a transaction, more or less. Yes, Anthony Kivai.
I want to say that I think it's the separation of privilege is based on the fact that not in almost every system, not every user does the same thing. So they're supposed to have different privileges because they access different parts of the system. And I'm not sure about this, but I think also when you separate different parts of the system, maybe let's say if your system has a database server, a web server, and all these different aspects that makes the system, they're also supposed to have different privileges, or they don't all have the same privileges to do certain functions. So
well, they have different tasks, so specialized for different activities, more or less.
Yeah.
Okay. That focuses more towards isolation, a bit of least shared mechanisms. But yeah, it's a good perspective. Yes, Jesse.
I just wanted to give a more practical example.
Yes, please. We are void of practical examples.
Okay, so I wanted to give an example of two-step verification, where you have to, for example, using Gmail, it has an option where you might be knowing the password, but it has to send a verification code to your phone before you access your Gmail account or something.
Okay, fair point. Yes, when you have multi-factor authentication, it will also fall under that. You simply need more than one attribute for you to be able to access a service. Isaac, you still have something to say?
No, sorry. I forgot to lower my hand. Sorry.
Okay. So, yes, the idea is to have, in most cases, multiple individuals verify a transaction. For example, you need permissions to modify a file. You might ask for the permissions from, say, your administrator or your supervising officer, and this person will give you privileges, but then this will probably need to be verified by a different individual, maybe the ICT manager. So having a different individual confirm or verify a transaction, simply part of separation of privileges. There are multiple examples that fall under separation of privileges, from banking to security to escalation of issues. So when you have escalation of issues, then you raise a ticket, someone addresses a ticket, and maybe another person confirms that the thing was actually solved. Sometimes they take it a notch higher and they have another individual, probably from quality assurance or quality control, confirm that the ticket was actually solved within some acceptable timelines and to your satisfaction. You could have the same scenario for banking, when you withdraw money from ATMs, then you have multi-factor authentication from that point of view. The card is chipped, has information, and you also need a PIN. You could have key fobs that need to be authenticated, and you also need to provide a passcode or passphrase for that. So having multiple attributes considered before a transaction, before an event is actually allowed or permitted, is actually what we refer to as the separation of privileges. Then we have the principle of least privileges. Yes, Waweru? Oh, couple of hands. Okay,
Hello.
we can start with Waweru.
Yeah, so I have a question on the
Yes.
the last bit for separation of privilege. Where it says the principle is also applied to refer to any technique in a resource, e.g. a data set is divided into parts whose access is limited to a specific to the specific privileges. Could you kindly like give a scenario of something like that?
Sorry, repeat the question.
It's the last statement in the separation of privilege, where it explains that in any technique in a resource, e.g. a data set is divided into parts whose access is limited to the specific privileges. Could you kindly like elaborate more on that?
Okay, I will do that. Yes, Tara. Tara Kadeni. Okay. Blaze.
Can you hear me?
Yes.
Okay. I was saying least privilege is whereby a user has the least, say.
Okay. We can hold on to that thought, Tara.
Okay.
Before we get to this privilege, so that we can finish with separation of privileges.
Okay.
Yes, Blaze.
Mine was just to ask about the last part that Mathenge asked about that principle is also applied to refer to any technique in a resource. I really don't understand what you mean in that case.
Okay. Roseanne?
I wanted to answer on least privilege.
Least privilege. Okay, you can hold on to that.
Okay.
Rebecca?
Mine is actually a question.
Okay.
What's the difference between least privilege and fail-safe?
Fail-safe.
I've
Okay.
not understood like exactly
Separation of privileges or least privilege?
least. Sorry, I've read the next line.
Okay. Who's next? Stacy.
I wanted to try help out with responding to the question on separation of privileges. The last statement.
Please go ahead. Okay.
The principle is also applied to refer to any technique in source. For example, a data set is divided into parts whose access is limited to the specific privileges. So an example is like in a bank setup, there are some systems that could have, okay, let me give an example. There's a system on where you can check account balances and locks that are made on accounts. Now, on the same system, some users are allowed to check account balances and check if accounts have locks, but don't have privilege to edit account locks, like dropping locks, which means in the same data set, some users are able to only view and maybe update, but can't delete. And other users can update, delete, and have more privileges than others, but on the same data set. Yeah.
Yes. To mean probably an individual who gives the authorization to change does not have the privileges to change. but they can view. So they can view and confirm that probably X happened, therefore authorize another user to change the values in that case. Yeah. In some cases, when you look at probably defining privileges, user privileges, you could have a user who needs some particular sets of maybe write and execute privileges, and the person they ask for the privileges doesn't really have the permission or the privileges to grant these privileges, but verifies whether the user actually needs these additional privileges. Yeah? So we have one user verifying that there is need for these privileges that have been requested, and then there is escalation of the request to the user who actually, what's the word, cascades the permissions to the user who needed the security privileges. So you realize there is need, then there is the person who verifies but cannot do it, and there is another individual who does that but is not in a position to do the verification. So that is what that last phrase means. Yeah? I hope that answers the question. Thank you for the example, Stacy. I think it also suffices to explain that last point. I hope that answers the question. Yeah? Blaze and who was the other one? Was it Wawero?
Yeah, it explains. Thank you.
Okay, yes, Tara, you can tell us about least privilege.
So about least privilege, basically explains that once a user is done, okay, if a user requests rights to carry out an action, the rights must be withdrawn immediately the action is completed. Say, for instance, like how we are in Unix, when you want to read or write on a file, immediately you're done, the rights must be withdrawn.
Okay.
Yeah.
Okay, fair enough. Yes, Rebecca.
Sorry, I forgot to lower my hand.
Okay. Okay, so in least privilege, the idea is users should have the lowest possible level of privileges or rights to do what they need to do on a routine basis. Yeah, they should have the lowest level of privileges to allow them to do their normal routine tasks. Yeah. Now, in some cases, we have some manual overrides. Users are given probably slightly higher levels of permissions to be able to probably bypass a problem that or a challenge that wasn't factored in, but the privileges should always be revoked. Yeah? If we have a user who's also the admin, whenever they are doing tasks that are related to the user, tasks that are only meant to be done by the user as a normal user, then they should use their user accounts and not the privileged accounts that they have access to. Yeah? So the idea is to simply have the lowest level of permissions available to a user for them to do their normal tasks in that particular system or application. Yeah? Now, there was a question where someone was asking the difference between least privilege and fail-safe defaults, I think. Now, the two are different in the application areas. Yeah. Now, fail-safe default simply means if we want to limit access, then everyone doesn't have access unless we give them access explicitly. In this other case, we look at a user who's performing tasks in an environment where we have mechanisms to grant or deny access or to control access to resources. So in this case, we look at what do they need to do their tasks. If these users are simply there to access a resource, to view marks, view their attendance, then they will always have that permission, read permissions only. If we have users who need to do read-write permissions, then they will only have that and they will not have maybe execute permissions. If they need execute and nothing on read or write, then they will only have execute permissions. So one is more of an operational point of view. One is more of an implementation of a mechanism perspective. So I hope that answers the question. Then we have the least common mechanism. What do we mean when we say we should follow a principle of least common mechanism? Miriam, Mboga.
Yes.
Yes. Least common mechanism.
So from this, I think that the mechanism tries to limit the way, like it limits a possibility of corruption in that if the mechanism allows sharing, so like let's say the sharing of data such like in a website. So if the website allows data sharing, that means that that mechanism should not be like made open to unauthorized users or people, because this could corrupt the channel that is being used to share data, and as such it can like make other systems vulnerable, like their databases or their private access keys.
Okay. Okay. Aubrey Omondi.
Yes.
Mm-hmm.
Hello.
Least common mechanisms.
Okay, so I think the way everyone in an organization should access a particular resource should not be the same, because if it is, if I'm able to, let's say everyone just needs a particular tag to access a particular building, that means kind of one of them would be vulnerable and the entire organization would be. So definitely we should try and avoid having everyone access a particular resource the same way.
Okay. Okay. So this principle tries to reduce the number of shared channels or shared resources. For example, you have users with different accounts, and these users have different resources in terms of memory space, storage space, processes that access the CPU, and so on. If we have users accessing resources on a network, then the number of shared links should also be reduced to the lowest possible values. Because if I am sharing the same access link and I overwhelm the link, or I more or less lock out everyone else from accessing the resources. If you have virtual machines, you still don't have shared memory space, shared processes, shared storage space, yeah, or blocks on your drive, yeah. So the idea is, if this was shared, then it will be possible for one process to corrupt the data that will be used by another process. Yeah? If you have an e-commerce application, if remote workers, teleworkers access the organization the same way as customers who make orders, then if we have a sudden sale at this point, probably due to COVID-19, then the orders will certainly overwhelm the system, and teleworkers will not be able to access the system as well. So we need to have separate channels of accessing resources in an enterprise. Yeah. So the idea behind this principle is to reduce the shared channels of access or shared resources that we use to access other resources to the lowest possible levels. Yeah. Then we have the principle of psychological acceptability, which refers to what? Nicole Muswanya. Psychological acceptability. Yes, Kesley.
Okay, it's actually a question on the previous principle, or least common
Okay.
mechanism.
Okay.
I'm not so sure if this example is correct, so I just wanted you to confirm whether it is, and if it's not,
Okay,
correct.
go ahead. Go ahead. Okay.
It's like when you mentioned the virtual machines, could it also be
Yeah.
the way we set up like our network interfaces? So like a virtual machine might end up having a different IP address to the host machine, or it might have the same IP address as the host machine. Like, could that be a way that principle is
It
being
is. It
employed?
certainly is. Yes, you could have the NAT scenario or the bridged network interface card, or you could use the host's network interface card. Yeah. The idea is, at some point, you might want to have sort of separation of data. You want to keep track of what information is meant for the virtual machine and what information is meant for the physical machine. And it's the function of the hypervisor to do the mapping. Yeah. So the idea is, in some cases you can have the same, and it's desirable to try and separate them, especially if you want, say, the virtual machine to communicate with the host machine as an independent entity. Yeah? Sometimes you want the virtual machines to have an internal network, which is a virtual network of all, say, virtual machines. So you see, all these machines will need to have sort of independent, in quotes, interface cards, and consequently IP addresses and MAC addresses that that they can work with, so that they can operate a bit more independently of the physical device. Yeah.
Okay.
Yes. That's fine. Okay. Yes, Nicole, you were saying something on psychological acceptability.
Okay. From what I understand for psychological acceptability, it's that when the security is being implemented, it shouldn't frustrate the user such that they have to keep, like it's a hindrance to their work because of the security protocols.
Okay.
Yeah.
So there are two closely related principles, psychological acceptability, and another principle, I'm not sure if I included it here, least astonishment, should be there. Yes, the idea behind psychological acceptability is it's inevitable that we will always have security mechanisms implemented to try and safeguard the data and the processes accessing the data, and sometimes the users. Now, these mechanisms that are in place should not be too burdensome, should not be too hectic for a normal user in terms of how they access their resources. Yeah? So there is The mechanisms should not make it more difficult, more hectic, or more unnatural for the users in terms of how they access the resources. Yeah? Other than that, these mechanisms should be in line with the mental model of the users. The users normally anticipate the mechanism to work in a particular way. Yeah? So how these mechanisms work should more or less be in line with the user's expectations. And that is where mostly the least astonishment comes in. Yeah? The least astonishment principle is a slight modification of the psychological acceptability principle, because the developers or designers of these mechanisms eventually understand that it's going to be different when we have mechanisms in place. For sure, it's going to take a bit more time. It's going to be a bit more burdensome to access a resource. Yeah? However, this level of inconvenience should not be too far from the expectation of the user. That's where least astonishment comes in. But in psychological acceptability, the difference between having a mechanism in place and not having the mechanism in place should be as minimal as possible for the normal users who access these resources through these mechanisms. Yeah? So there is a question here. What will happen if having a mechanism is too hectic for users? What will be an obvious result? Yes, Isaac.
I'll give an example with something like, okay, let's say a system administrator is trying to set up a particular mechanism, and it's too hard for them to actually comprehend and set it up. They might actually choose not to actually set up a good mechanism and opt for one that is vulnerable. So at the end of the day, it causes a vulnerability issue to the whole organization, where the person is actually trying to actuate that particular mechanism.
Okay. Any other tip? Ilhan Ayan Kanan. Yes, Waweru.
So for my take is that the obvious thing that will happen is that users will get tired of using the system and will just opt to use another service by another, a competitor, for example.
Provider.
So,
okay.
Yeah, that's my take.
Yes, people might opt for a different service provider. People might opt to not use the mechanism in the first place. The administrator might opt to probably disable the mechanism for a particular range of users. Yeah? Every time I get to Strath, if I am the system admin, I have requests from a particular group of users who probably always forget their passwords, but remember after the third attempt. And maybe the mechanism tries to lock an account that attempts to log in unsuccessfully, maybe 3 times in a minute. So what happens? I will get a request probably from one of the users who says, I tried it 3 times, but I think I now remember my password. So the administrator might find it easier to probably disable that mechanism for a particular account, for a particular user role, so that they also have less time, they can spend or have less effort in trying to reactivate these accounts and lock these accounts every morning or every week. Yeah? So the obvious downside is the mechanism is most likely going to fail, yeah, because users will not want to work with it. Yeah, so either users will avoid using that, or the administrative entities will try and avoid the implementation of that mechanism for all users or for a particular set of users. Yes, Naomi.
Could you kindly explain the difference between this point and the first point?
Which point and which point?
Between psychological acceptability and economic
economy of mechanism.
Yes.
Okay. Okay. So what is the difference between psychological acceptability and economy of mechanism? Naomi asks. So any takes? Okay. So economy of mechanism, you're looking at it from an administrative user's point of view, yeah, or the person who's coming up with the mechanism that you want to implement. Yeah? Now, for example, you want to ensure that all user accounts are secure, or more or less have some degree of security. Yeah? So you enforce some password rules. You want some particular length of passwords. Password changing probably every 2 weeks. You want some level of control such that if a user tries to log in or they do not get the correct password within a particular duration of time, then the account is locked. We also have users who, if you need permissions, then you can escalate the issues and so on. So you might have all this range of privileges or permissions that can be given, or mechanisms that can be implemented. Now, the idea behind the economy of mechanism is you're looking at a particular facet. Sorry, there was a question. So when you're looking at a particular facet, say you're looking at mechanisms to ensure security of user passwords. Yeah. Now, if having a password policy, strong passwords, and frequent changing of passwords, if that is enough to ensure that security of user profile is guaranteed, then we should have that. Yeah, we do not have to add biometric prints or images for users, and add provide fobs for users, so that we can have all these mechanisms to try and simply control how users access workstations, for example. Yeah. So if you have one, and we could always tell, maybe when we have breaches in passwords, we have brute force attacks. That means we have 1,000 attempts in 2 minutes. Then we have economy of mechanism. We simply have one security mechanism that simply provides security for user profiles. Yeah? Now, if we have the same mechanisms in place, now psychological acceptability comes in when Naomi, as a user, asks me every morning to probably unlock their account because they used the wrong password more than 3 times. So in this case, I will probably go to Naomi's account and probably exempt him from from having this mechanism that looks at how many attempts do you have in a minute. Yeah. Probably in a different occasion, you might want these users to always lock their accounts every 30 seconds of inactivity. Yeah. But I probably need to consult every now and then. And every time I consult, I might get past 30 seconds of inactivity. Then I might go to the local device and deactivate that security feature that locks my PC every 30 seconds. Now, psychological acceptability looks at what is the perception of the user with regards to that mechanism. The economy of mechanism looks at how many mechanisms do we need to employ and have in place to secure one facet of security. Yeah? So one focuses on the individual user's point of view in terms of how that mechanism affects their ability to do their tasks, to access the resources they need to access. The other one, economy of mechanism, looks at how many mechanisms can we have in place to try and provide security. Of course, if we do not have economy of mechanisms, for sure we might end up having that lack of psychological acceptability. Yeah. So we might have a cause-effect relationship, but there is a difference because one is from the perspective of the end user and one is from the implementation point of view. So I hope that helps. Yes, if you want to answer the question in the text, you can also do that in the chat. That is also fine. So I hope that answers the question. Okay. So we have isolation, we have encapsulation, and we have modularity. These principles are related in some way. Isolation implies segregation of, say, the network or the enterprise. Yeah. So you segregate the network or segment it into different components, and the different sections have different levels of access, so to speak. Yeah? There are segments that can be accessible by the public, for example. So in that case, you will probably have a DMZ, which means anyone can access it, yeah, with limited security measures. We could probably have the internal network with a management segment, which is probably secured and has just a few individuals controlling that bit. Yeah? We could have a department within the internal network that probably has limited access, and we could have part of the internal network that is accessible to everyone. So isolation looks at three different perspectives, more or less. One is isolation of resources that are considered critical that either should not be accessible to the public or components that should be accessible to the public. So the idea is to have segregation of these resources so that we only have disclosure to entities or people who should have access to them. Yeah. We could also have isolation of individual user processes. Yeah? So what a user will do will not affect what the other user does. So sort of moves towards least shared mechanisms in that you do not have overlap of user processes in terms of the resources they have access to. We could also have isolation of security mechanisms and look at these security mechanisms as individual components, yeah, that plug into the system to enforce a particular rule. Yeah? So isolation simply looks at that element of segmentation of what is publicly accessible, what is private, and what is not even accessible within the private network. Then we have encapsulation, which I think you guys can tell me more from your programming point of view. Then I will add one perspective from the network point of view. So what do we mean when we speak of encapsulation? Encapsulation. Yes, Jerry. Vaga.
Okay, encapsulation from an object-oriented programming perspective is about wrapping wrapping certain functions and attributes into an object. Yeah.
Wrapping something into an object.
Yes. Yeah. Basically, encapsulation is implemented through instantiation of objects from a class.
My goodness. Okay. Let's assume we are now in an ISST class and not an OOP class. Doesn't mean you're wrong.
Okay. It's basically creating a new instance of a class. Okay, when you create a new instance of a class, that object has the attributes and the functions. Okay, yeah, the attributes and the methods of that class. So, yeah, so basically you've through encapsulation you tie those behaviors and qualities from that class into the object. Yes, that's what encapsulation is.
Okay. Any other take? Let's see. Kari Joshua Wadawi. Helen Kukach. Lorna Kamau. Okay, so in encapsulation, you're simply creating a logical boundary within which resources can be accessible. Yeah. So these resources will only be accessible if you are within that boundary or within that class, as Jerry was trying to explain. Yeah? So you can only access the data and the functions or methods in a particular class if you are an object of the class or sort of related to the class. Yeah. Well, in some cases, you might be able to access even if you're not part of it, as long as there is how do we call it? There is permission of access from external entities as well. Yeah. But encapsulation simply tries to create that logical boundary that defines the resources that can be the resources that are within this logical boundary can only be accessible by can only be accessed by objects or subjects that are also within this logical boundary. Yeah? So from a network's point of view, you normally have active directories, and these active directories define the domain. Yeah? For example, in Strath, there are normally two domains. There is the Strathmore domain and there is the student domain. So if I belong to the Strathmore domain, then I have to request access or request permission to access resources in the student domain. Yeah? And from the student domain, in some cases, you might also need permissions to access resources in the staff domain. So the domain simply provides that logical boundary, and within that logical boundary, you have a central point through which resources can be administered and in some cases can be replicated. So this domain more or less provides some sort of encapsulation through which resources can be accessed. So normally there are boundaries. You can create a linkage between these logical units such that a person in the student domain can access a resource in the Strathmore domain and vice versa. But without that linkage, then only people in the student domain can access resources in the student domain, and people in the Strathmore domain can only access resources in the Strathmore domain. Yeah? So the idea is that logical exclusion or inclusion, depending on how you want to look at it. So I hope that that is clear. Okay. So can we say isolation is a form of least common mechanism, like in the case of virtual machines? Yes, isolation will be one of the ways to try and reduce the shared mechanisms. Can we say that steganography and cryptographic algorithms are ways of achieving encapsulation? As ways of achieving encapsulation? Yes, Kevin Chemjo.
No, mine was actually another question. I wanted to ask whether abstraction and encapsulation is the same thing.
I will answer the question if I was in an OOP class. So what is abstraction from an OOP point of view? Kevin, what is abstraction?
Yes.
What is abstraction?
Oh, so I guess abstraction is basically a form of hiding complex elements. We are not showing the complex operations that happen underneath.
Okay.
Yes.
So you're asking the difference between encapsulation and abstraction?
Yes. Okay, it kind of sounded almost similar when, yeah, from my interpretation, basically.
Okay. So our APIs are a way of providing encapsulation. Okay. So by you defining that that logical boundary, you are more or less doing encapsulation. Now, in abstraction, if I remember my OOP correctly, or my understanding of it, in abstraction, what you're doing is it's an element of encapsulation, but the idea is you're not accessing the elements or the implementation details of something. What you're doing is you're accessing the functionality. Okay. For example, when you do web systems, you do not access the nitty-gritties of the script. What you're accessing is the functionality that comes with the execution of the script. Yeah. So abstraction is hiding the implementation details by providing the functionality itself. That's my understanding of abstraction. Yeah. Then by having logical units that have resources or other logical units within them is what encapsulation is. Yeah. Then our APIs are a way of providing encapsulation. Yes, could be. Yes, it could be. It could be because there are particular items, data objects that are only accessible within the API or within applications that have access to the API. So yes, it could be a way of implementing encapsulation. Now, there was a question on cryptography and steganography or steganalysis. The two are more of data hiding or data scrambling concepts. So they don't really define a logical boundary. What they do is they try to hide the data from access to individuals who shouldn't have access to them. Yeah? So by having the algorithm known, the image that was used known for steganalysis and steganography, and having and the algorithm known, we are more or less having a digression towards open design, as Timothy says. Yeah, but not encapsulation. I do not see how they will fall under encapsulation mechanism. So is it correct to say that the two are simply encoding techniques? Yes, encoding simply means representing data. So if you represent data from one format to the other, from text to image, from text to ciphertext, then that will be part of encoding. Yeah? So encoding is not limited to analog to digital conversion or different encoding schemes like Manchester and differential Manchester. So could be some form of encoding. In fact, it is encoding. Okay. Then we have layering. Now, layering comes in especially when you look at security from what we call defense in depth, a defense in depth point of view. And the idea is to look at the resources and the infrastructure as sort of complementary units in security. Yeah. So layering looks at, again, segmentation of the network. It's actually very similar to modularity. So segmentation of the network, and then the implementation of mechanisms across the different segments. Yeah. Now we could have mechanisms to protect the network. We could have mechanisms to protect the hosts. Then we could have mechanisms to protect data, to protect applications. We could also have all this defined by some policies and regulations. Okay, so by having security mechanisms in an additive fashion, such that they improve on the weaknesses of the previous layer, is what this layering focuses on. Yeah? For example, we have rules and regulations, policies that define what is acceptable. Yeah? Then we have proxy servers and address translation routers that will do basic filtering, so you can filter what comes into the network. Then you have a firewall with limited rules for the DMZ, so that external individuals can probably do orders from an order server in the DMZ. Then we have stringent rules as you get into the internal network. Then within the internal network, you can have intrusion detection and prevention systems. You could have unified threat management. Then from that, you could have anti-malware, anti-spyware on the hosts. Then we could have security patches for the operating system. We could have proper configurations based on best practices for particular applications. So you realize there are additional or additive measures in place from the ingress device from the network coming into individual users within the internal network. So that is what layering will refer to. Yeah. So any obvious downside in layering? I think there was another question. Any obvious advantage of or disadvantage of layering? Yes, Calvin.
Could we say it's costly because you're trying to implement different mechanisms? And I have a question: if you are using the different mechanisms, will there be collision, some sort of collision?
Okay. Yes, you could have cost as a downside. You have very many mechanisms in place. Now, based on the economy of mechanism, you're having the most effective mechanism for every layer. You do not have multiple mechanisms per layer. So if you had multiple mechanisms per layer, then you will have collisions, in quotes, as you put it, or you will have conflicts. However, if you have mechanisms that are different at different layers and that are optimized for security at those layers, then you will have mechanisms that are complementary in nature and not conflicting in nature. Then is the use of microservices meant to enforce isolation and or modularity? Now, when you have these microservices within sort of containers, then do these microservices do they have their own security mechanisms, or do they get this from a particular module for security? So if they have security measures on their own, then we could say it's an aspect of modularity. Each of these microservices can sort of exist on its own. Yeah? Now, additionally, when these microservices are stored, or when they have access to the physical storage or physical components of the PC, do they share these resources? If not, then that is isolation. If they do, then they lack isolation. I hope that answers the question. Stephen. Okay, so I think
kinda, but I was wondering where the service from intelligence lab
sorry, I can't hear you clearly.
services, yeah?
Yes.
They share intelligence from like some lab, but all of them have their own individual security measures.
Okay. It's a very good example of modularity. Yeah. It's also a very good example of isolation because, again, they do not share the physical resources. Yeah? So it is end. So enforcing, it will be nice in enforcing isolation and modularity as well.
Okay.
Yes. Yes. Then in layering, does the next layer depend on the previous layer? Yes, it does to some level.
So does that mean that if the next layer depends on the previous layer, does that mean that the lower layer, let's say there's a breakdown in the lower layer, the other layers will be affected?
Yes. For example, if I am, for example, you are working within an enterprise, you have the latest operating system patches, security patches. You have host-based anti-malware applications that are very nice. The application you're using has updates well configured, but then your firewall fails. Then it means if it's based on permissions, as we said in fail-safe default, then it means at some point traffic that was meant to come in, data that you could access from the internet or from an external network will not be accessible to you. Yeah, so the data will not be available. Availability is a component of security. So if you can't access the data, then it's basically not helping. Yes. So that means the system as a whole fails, especially in availability, in the availability aspect. Yes, layering will certainly affect psychological acceptability, because if you have so many security mechanisms in layers, then it means access to data will take a bit more time and a bit more effort. Yeah. So what you should probably focus on at that point is more of least astonishment than psychological acceptability. And least astonishment focuses on many things from an ICS point of view: good programming principles, proper messages, proper feedback for the users, proper outlines and interfaces for the users as well. Yeah? So any other question? So I was hoping we will finish slightly earlier. There are a couple of questions for you guys to look at. So you can look at them in groups or as individuals. Try to try to think through the questions and look at how to answer them. Yeah? Come up with your own answers and justify your answers. Yeah? So unless you have any questions, I think we can more or less call it a first chapter. You can indicate your details on the chat so that counts as your attendance. Yes, and if you have any questions, you can ask them or you can drop me an email and I will try to respond.